The Pi just crashed. This is our fourth reboot after freezing. Look at that, CPU pegged. This is pretty frustrating. Let's troubleshoot it. Let's disconnect it. Part 1, we did internet. Part 2, we built the Raspberry Pi computer, put all the hats on it, made it connect. To Part 3, the network build out. Today is Part 4. We're going to start working on the software and actually start bringing everything together into a functional navigation system. So let me talk about what we're setting up here. The thing I know the least about is what my navigation system is going to look like on the yacht I'm working on procuring right now. So if you've watched the prior episodes, I don't have that boat yet. I'm building for the future, but I'm also experimenting to make sure that if there are failures, I learn while on land, not on a boat. So obviously, how much helm space I have is the thing I know the least about. So the purposes of our test, we're going to build a helm station using a Puck Windows computer, pretty run-of-the-mill, nothing super fast. And so we'll let the Pi run all base systems, and then we'll let the Windows computer run navigation. I suspect that I actually would end up running with a Mac Mini, but none of this matters because what we're going to be doing is largely browser-based, a couple of applications that are available on both Mac and Windows. So just have a couple of monitors available to me. I would like dual screen. None of this is likely what's going to end up here. And so I'm powering this stuff off 120, but obviously I could do that on an inverter, or I could find a way to do it via 12 volt probably if I want to do that. So we'll connect Ethernet into our network. Let's start actually getting stuff plugged in. No Wi-Fi card in that computer because I want to use the LAN connection. So there we are. We show connectivity. Use a keyboard and a mouse that we have laying around. We will need speakers as we don't have anything built in. And we can boot up. Now, as I've said before, I have previously configured this to work with the Pi. Today's not going to be the end-all on how to configure this software. I'll talk through what I'm using, I'll show you what I'm using, but there are better videos of how to install OpenPlotter, for example, or Signal K. But I'll show you what we're doing here. Computer's up. Let's test if we have internet. Okay, we do. We are running through our Wi-Fi that we had set up earlier. So I'm going to log in to the GLINet Spitz. This is our internet router, and just check our configuration. It's been a while since we did that video. We are picking up a cellular connection from AT&T, and we are repeating my home Wi-Fi. So that's what I want to have happen. So let's do a speed test. The modem should be prioritizing the home Wi-Fi over cellular. I will say I'm very far from the router here in the house, and so I'm fine with these speeds. I mean, if I moved closer, they would be better. But for the purposes of what we're doing, again, we're not looking to run Xboxes or stream movies. This is about having a reliable system on the helm to do different things with. I am going then to VNC into the Raspberry Pi. So to explain this a little bit, I have the Pi on the wall. I could connect a monitor and keyboard and mouse to it directly, but I probably won't choose to do that way on a boat. And so being able to VNC to it, again, this is basically like connecting to your server. You shouldn't have to do it every day, but let's go take a look at what we're seeing. Meanwhile, let's look at our OpenPlotter version. So OpenPlotter 4 is out, which has a number of upgrades over 3, and I think we need to start with a fresh install. There's not really an upgrade path for it. It's probably a dangerous upgrade, meaning chance of failure. I'm kind of inclined to start fresh, essentially meaning I've got to reconfigure everything. But then you get to go along with me. Let's do it. All right, we're going to start with a new installation of OpenPlotter 4. To do that safely, We're gonna pull and save this SD card and use a new SD card so I can always go back to it. But let's take the opportunity to change this fan out. You heard me complain about the fan. And so we're gonna go, that's a 12 volt fan. We're gonna go with a 5 volt fan because we have some 5 volt pins on our PiPower that I'd like to see if I can power it from. So first thing we're gonna do is pull this plate out so we can get to those pins on the backside. Gonna be interesting to see our PiPower working because we have now pulled all power from it. So we're still getting power from the PiPower. All right, let's pull this out. We've definitely still got power to the Pi, so we're running off our PiPower backup right now. There is an on-off switch, which my understanding is it will safely shut down the Pi. Doesn't look like it did, but we'll see. So we'll deal with that in a second. I did find a schematic for the PiPower. So what I'm interested in are these 5 volt pins. So we're gonna pull it off the backer board, see if we can get to those, and see if we can power up this 5 volt fan, which again has good reviews on its bearings and all that, so hopefully it's gonna work. Gotta get these pins here. Take these off. Okay. I see the positive on top, the ground on the bottom. If we put this on 2 of these pins like that and power it up, we do get power. The fan blows toward the label. So we're gonna pull air out, pull air through it. Let's turn that off for a second. Let's get the Pi back on there. All right, it's a nice tight connection. Let's try it one more time. Move some air for 5 volts. All right, I'm gonna go ahead and pull the SD card. We'll store that somewhere safely. And then let's get this back in its case and pull the other fan. 5 volt fan in. And turn it on just to make sure we're connected. Backer board back on. Let's go ahead and reconnect everything. So even with the PiPower off, we're going to get a connection to NMEA 2000. So we are ready for an OS. But for the first time, we can actually test safely sealing the box. And we are moving air through. So I'll probably test that with a temp meter and see how hot it gets. That's the idea of the closed box with the fan running. So temperature just on the board is 84 degrees. Temperature on the box is about 86 degrees. So let's watch that. Let's see how hot we get. All right, let's work on installing OpenPlotter 4. I will say, as a guy who rarely reads directions and often throws them away, that when I first did this with OpenPlotter 3, I actually found the instructions all throughout are very good. Let's protect our old SD card. I'm gonna write OP3 backup on it and put it away. All right, so I've got a new 128 gig Lexar micro SD card. I don't have a way to get SD to Windows, so I'm gonna use my Mac for it. We need Raspberry Pi Imager. Let's get OpenPlotter 4 on the Mac. I'm gonna download OpenPlotter starting, has almost everything you need. These other versions are just configuration. I'm gonna download the touchscreen version, which will enable touchscreen on the Raspberry Pi and the mounted monitor. Download done. We do not need to unzip it. Let's go to Raspberry Pi Imager. And we are a Raspberry Pi 4. We are going to use a custom image from the computer. And we are going to choose next. I'm going to choose no on OS customization. Yes, we're going to override everything. And we are writing. Okay, write successful. We take our SD card and slide it right in. Let's see if we can do it with a pair of needle nose. Card in. No way to film that. See what happens on our boot window here. Okay, we got a Raspberry Pi desktop screen. Looks like OpenPlotter is doing its thing, starting to unload. Startup finished, no errors. Let's see if we have VNC running. So while we're backing up, we're ready to move on. I think the Pi just crashed. So let's manually restart it here. I mean, that was a lot of data flooded into that at one time. We're back up. Let's run our check system because the CAN bus did appear here a second ago. CAN 0 is working. Signal K is running. So let's open Signal K. We appear to be crashed again. Okay, we're rebooting again. We're alive, maybe. We are getting NMEA connections in, and it looks like we froze again. This is our fourth reboot after freezing. We try something a little different here. Rebooting again. I'm gonna check VNC to make sure it's running, and then I'm gonna stop. I'm gonna do everything else on the Windows PC. And we froze again. All right, too many lockups. We're gonna try a SanDisk Extreme card. I did some spec review. I think this could be it. It also means we're starting over, but I'm okay with that. We did a lot of experimentation on that first run. Okay, here we go again. New card in, still attached from the PiPower. No USB connection. So we're gonna go in a more specific order here. Okay, we are booting. So again, fresh install. Turn on VNC so we can go down to the Windows PC. Okay, updating configuration. It's not the finest touchscreen ever. We're back to our defaults. Raspberry was the default. Let's just do a couple things while we're here. Let's look at Task Manager. So this is much better than what we just saw. CPU usage 1%, memory 15%. So that is considerably better than what we saw earlier. All right, so we're gonna have to do the hat config from Copperhill Technologies. We want the guide marked September 2023. We have it. Sudo nano boot firmware config.txt. Rather than retype anything, let's paste exactly what we need in there. Save buffer, save. Turn on UART by going to Preferences, Raspberry Pi config, and under Interfaces, we want Serial Console off, and we do want to reboot. Rebooting, I'm going to check terminal every time. Okay, no Signal K interface for CAN 0. That I think is a good sign, because we haven't done that yet. But I also predict it is showing terminal 29%, 25%, running a few more things, dropping down, memory's still good. Now we did not get our CAN 0 error. Now we're gonna do a CAN dump. We are getting data. We're doing much better than we were. Step out of that. We gotta do our startup config. One time. This is all from the Copperhill Tech manual. We're going to copy this. Okay. Control X, save, write. Okay. Remember I talked about the rudder sensor needing to be grounded? I'm going to ground it real quick. See if we get it in our connection list. Alright, so that is coming out of this guy. I did not see the GPS antenna show up. I'm going to disconnect that and reconnect it and see if it will show up just by doing that step. Okay, back up after reboot. We're going to keep looking at Task Manager. So we're doing well. Nothing to be concerned about. We are good with our configurations there. I am going to change my host name and my password. You don't need to change your host name, but I wanted it changed. Let's go to CAN bus. We do see the CAN 0 interface. I think we're gonna have to set up Signal K. Now let's send, so in Signal K we have to add our connection. Server, data connections, add. It is NMEA 2000. Let's call it NMEA 2000. We're going to use CAN bus, which is CAN boat.js, and the interface is CAN 0. That is saved. On a restart of Signal K, we're going to start getting that data. We are seeing it here too. So now we are pushing data into Signal K. Let's look at our data browser. What do we have connected? 3 devices. More sensors, but 3 devices. This is GPS, that's 1. This is the CX5003, so that's 2. This is our steering rudder indicator on the CX. Now, let's go back to serial. We just froze, but maybe I have an idea why. Okay, basic troubleshooting. It froze on the addition of the NMEA network. So, if we see the CPU and memory pegged again, we're going to start removing NMEA devices until we see it not pegged. Look at that, CPU pegged. Okay, so we've already frozen again. So I pulled the CX5003 off. Okay, back up. Task Manager. CPU pegged. Okay, now I'm going to pull more off the network. Okay, now we have nothing on the network. Alright, so this is pretty frustrating, but I actually feel like we are at least identifying the problem. I mean, we're gonna figure out what's pegging the CPU, and I think that's what's killing the system. Okay, interesting. Our CPU usage and memory are back to what we were expecting. One of those NMEA devices must be pushing an enormous amount of data. All right, we're gonna slowly, one at a time, hook things up. The Hat Labs device, which has 1 sensor on it, is the one I think is least likely to be a problem. It's hooked up now, just pegged. The one I think is least likely to be the problem, just pegged. Now let's see if I can disconnect it before we lose it. Okay, CPU usage is good. I'm gonna hook up a different NMEA device. If it pegs this time, I'm gonna assume it's Signal K itself. Now, connecting the CX. Okay, connected. Assume we're starting to push data. Okay, and we are getting data. Let's hook up the GPS antenna. GPS antenna is connected. We're now showing the data. CPU is still not pegged. Okay, so we're gonna leave that disconnected right now. But I want to get the serial device hooked up now. Plugging in the USB hub. Only thing on it is the Daisy AIS. If we refresh, we should see another device here. Let's give it an alias of AIS, and then we have to go add it as a connection. So on the connection, we're going to add to Signal K, and it did want a 38,000 baud rate. And we're going to refresh. We see it as green. We have the connection over here. Task Manager. Still doing fine. It's really interesting that that Hat Labs device was pushing so much data. It's really interesting. That's not where I thought this would have failed. So it's satisfying to figure out the issue. So let's get KIP installed and updated, and then we're gonna let this run for a while. Let's shut down and put our PiPower back on. So we gotta get the studs in for this board. This little precision screwdriver kit I got on Amazon is really good. We're booting up. Again, this is what we have disconnected. Our sailor hat with ESP32. A little disappointed about that. I'm gonna look further into it, because again, that was what connected all of our one-wire sensors. Did you know that only about 10% of you who watch these videos are subscribed to this channel? Take a look at this. We'd love to see you subscribe now. Click that bell. That'll tell you when the new videos come out. You'll see what we're working on next, which is pretty exciting. We'd love to have you part of our community. Let's start configuring KIP. So KIP is one of the dashboarding solutions built in, and it is not a database. So it doesn't connect to a database, it connects live. We do have our connection. And we're going to plug in our password. Automatically change between day and night modes, okay. We may mute those audio prompts later. So this matters. Remember when we were talking Kelvin earlier? Angle degrees, volts, liters, let's go with gallons in America, degrees per minute, watts, charge amp hours, pressure we're going to leave right now, amp ratio, speed in knots, flow, gallons per hour, Fahrenheit, time in hours, feet, length in feet. When you save current configuration to server, then you can load it. And so I like to do that because I don't want it just on the PC. I want it on the Pi, and I want to be able to pick it up from another browser elsewhere. Let's see if we can mimic a Meritron display in KIP. Just looking at what we have here, we're going to need 1, 2, 3, 4, 5, 6 columns. So I think we'll do a radial gauge. Make it be that size. And then we need to split this horizontally. We need to split this vertically. We need to split this vertically. And here we're going to do another radial gauge. Okay, before we go much further on KIP, we're going to install a couple more sensors. And again, everything's going to be in sort of a demo environment. So I'm going to put a one-wire sensor on the CX5003. I'm going to put a pressure sensor, which would be mounted in an engine block on the same device. And so, I mean, obviously we're not going to get any real pressure, but whatever the nominal pressure is in the environment, we should be picking up. So to do that, we're going to install, most of these require power. So we're going to install some 12 volt positive and negative distribution blocks. These are not marine rated. They would not be used in a marine environment, but for demo purposes, they're super cheap and they're going to work really well. So we're going to power down the CX, put the power that I brought in on terminal blocks down here, and then power it back up. All right, so first things first, I'm going to go ahead and get these jumpers in here. Let's put the negative in. So now we're going to pull positive and negative, and we're going to wire the supply side power into the distribution position 1. Okay, clean those wires up later. Now let's take a couple, repower the CX. Ground in the first position. Positive in the second position. Again, we would have spade connectors on here. We'd be using a much higher end terminal block. Okay, so the CX should be online. On these pressure sensors, they appear to be one wire, but they're really not. They are installed in the engine. But this is your sensor, but this is a ground. So it would be grounded to the engine block, but it's not going to work if we don't ground. So let's get a connector on here. And then we're going to wrap this with some tape, but we're going to connect the ground part of it too, because we're obviously just simulating this. So we'll get this up on the board. And then we're going to connect one of these to our sensor and one of these to our ground. This is the ground wire, and I'm going to drop it in this last position here. So we're going to put this in the oil pressure position, which is 3 up. So what I'm saying is 1, 2, 3. And then we're going to put a one wire sensor in as well, which looks like this. I don't know if you saw that flicker. We just appeared to pull power way down. Interesting little power flicker there that pulled everything down for a second. Our amps and voltage dropped. Back to it. We're going to put this on coolant temp, the number 4 position. Okay, oil pressure, going to here. Coolant temp, powered, going to here. Let's see if we get it in signal K. Are we even getting the data? It's kind of interesting. We just got a, I've not seen the alternator voltage before. That's got to be coming from the CX with the .49. We are getting a starboard temperature. And we are getting a starboard oil pressure, which I'm assuming is okay, that it's 0. All right, so let's look at starboard temperature is 393 Kelvin. So first of all, let's go here and say starboard temperature. Display as Fahrenheit, 248 degrees. So that doesn't seem right. So it's 393 in Kelvin. Let's look here. Kelvin to Fahrenheit. Well, the conversion's working correctly. That sensor may not be great. KIP is working. I'm sure the sensor is not. Getting somewhere. We'll look later at how to do like warning labels where we're in the green and then we're yellow and then we're red. Let's do one more sensor, one more one wire on the port side. I'm just curious to see what it would read since that other one is reading so high. I mean, it doesn't matter for what we're doing, but curious nonetheless. Stick with our labeling we're doing. Still have this disconnected right now on the Hat Labs device. I will tell you something I'm so impressed with. So again, I bought this Sense ESP enclosure and little kit from Hat Labs. It's called a Sailor Hat with ESP32, and it's a small operation in Europe. And so I contacted them because I told them that something was sending a lot of data through, and without question, asked a couple of questions, and he immediately said, I'm sending you a new unit. Sounds like something's faulty. So didn't look up warranty period or anything like that, just said I'm sending you a new unit. So his name is, I believe, Matt Arias, but Hat Labs, love the customer service. We will receive that and do another video on it later. All right, so we're picking up coolant temp on the port now. We do now have a port sensor in. So it's interesting, 278 Kelvin versus 393. 278 is 40 degrees Fahrenheit, so I don't think that's right either. Again, for the purpose of testing, we're getting data. I don't think it has anything to do with signal K. This is all about the sensors used. They could be the wrong sensor. They could be not calibrated. All right, a question some of you must be asking. So our demo and this part about getting software running is really about two things. One is to get what is primarily historically analog gauges into a digital environment where I not only can monitor them digitally, I can monitor them remotely, but I could also do things with it. And so I can set thresholds that send me alarms and those kinds of things. Secondly, we have OpenCPN, a chart plotter. So my priority are really with the gauges and the analog information that has historically been very hard to get or very expensive to get. OpenCPN, I don't know, I'm gonna give it a try. I think it's interesting. It's got a lot of data, but as we know, like here's Navionics. It's hard to beat this. I want to navigate to a spot and it automatically auto route me. That's a feature that Signal K doesn't have, but I'll also tell you auto routing has its flaws. You shouldn't necessarily rely on it. So I am not suggesting this is all a replacement for everything. I'm suggesting that I could end up with a setup like this. But again, getting digital data from analog equipment is really where my interest lies. I'd love to see what I can do with OpenCPN too. All right, so let's finish up some just demo customizations. And so I'm gonna go to configuration, edit layout, switch back on my layout options. And I think I'm gonna put my rudder here. So we start, let's go here and switch this to simple linear and go to our path and just pick up, we gotta change our filter to all because we're just filtering for voltage on that default. Rudder angle. And we know from earlier that -45 is where we start, +45 is where we end, 2 decimal places. We'll call this rudder angle. Let's just go with the primary color. And, yep, we're good. So we're going to take that out of there. I am going to split. Nope, I always get that wrong. Split horizontally. Let's change our font label here to text, actually to number. Change our path and pick up our latitude. And I think we want it latitude in minutes. It's probably best. It is. Let's change this to numeric. Let's do our path again. Longitude in minutes. Okay, so there's our northwest, there's our rudder indicator. I don't care about decimals on that. We have our starboard temp. Let's change this to be our port temperature in Fahrenheit. Alternator voltage. These would be our tacks, which we're not getting anything from right now. So let's lock layout. I mean, pretty happy with that. You know, I was kind of mimicking a Meritron display. Again, our data, I don't care that our data is valid or invalid. On things like those temp sensors, they're $1 each. But I do have port temp, starboard temp, alternator voltage, which is reading correctly based on what my power supply is doing. Oil pressure is reading, it just is reading 0, which could just be the wrong pressure gauge. Latitude, longitude, rudder indicator, and rudder indicator works. So I am steering to port right now, I'm steering to starboard right now, and I'm recentering my rudder. So pretty happy with this. So there's so much more we can do with this. There's so much further we could go. This is the end of part 4, the major series. I probably will continue to do deep dives into different areas. I want to explore different dashboarding products. I want to explore more sensors. All in, I might be for $450. And from here on out, it would just be relatively cheap sensors. Thanks for watching. Let me know if you have any questions or comments. I'm not a pro. I'm experimenting. There's got to be better ways. I want to hear it.